For decades, Pluto was viewed as little more than a frozen world drifting in the darkness beyond Neptune. After losing its status as the Solar System's ninth planet, many people assumed its scientific importance had faded as well. It became a distant object that few expected to surprise us again. But space has a remarkable way of rewriting our assumptions. When the James Webb Space Telescope began studying the outer solar system, Pluto quickly returned to the spotlight. With its powerful infrared instruments, Webb can detect details invisible to previous generations of telescopes, allowing scientists to investigate icy worlds with extraordinary precision. Instead of seeing Pluto as a lifeless sphere of ice, researchers are discovering a far more complicated world. One of the first mysteries involves Pluto's atmosphere. Although incredibly thin compared with Earth's, Pluto's atmosphere is constantly changing. As the dwarf planet follows its long, elliptical orbit around the Sun, temperatures rise and fall dramatically. Frozen nitrogen, methane, and carbon monoxide can change directly from solid ice into gas, temporarily surrounding Pluto with a delicate atmosphere before freezing back onto the surface as temperatures drop again. For years, scientists believed this cycle was relatively simple. New observations suggest otherwise. Webb's sensitive instruments have detected subtle variations within the atmosphere that hint at complex layers and changing chemical activity. Tiny particles suspended high above the surface create hazes unlike anything expected on such a small and distant world. These discoveries suggest Pluto's atmosphere is far more dynamic than once imagined. The surprises continue on the surface. Stretching across Pluto is a vast heart-shaped region that has fascinated scientists ever since the first close-up images arrived from NASA's New Horizons mission. At its center lies Sputnik Planitia, an enormous plain covered primarily by frozen nitrogen ice. At first glance, it appears perfectly calm. But appearances can be deceiving. Careful observations indicate that this enormous basin has remained geologically active over relatively recent periods of time. Unlike heavily cratered ancient landscapes found elsewhere in the solar system, large portions of Sputnik Planitia appear remarkably smooth, suggesting that older impact scars have somehow been erased. Something has been reshaping the surface. One possible explanation involves slow-moving glaciers. Under Pluto's extremely cold conditions, nitrogen ice behaves differently from ordinary rock. Over immense spans of time, it can slowly flow across the landscape, filling depressions and renewing the surface in much the same way glaciers reshape valleys on Earth. This process transforms Pluto into a surprisingly active world. Scientists are also investigating another possibility: cryovolcanism. Unlike volcanoes on Earth that erupt molten rock, cryovolcanoes release icy mixtures containing water, ammonia, or other frozen materials. If such activity still occurs beneath Pluto's frozen crust, it would indicate that internal heat continues driving geological processes despite the dwarf planet's enormous distance from the Sun. That raises an even bigger question. Where would that heat come from? One possibility is the slow decay of radioactive elements hidden deep inside Pluto's rocky interior. Although the energy produced is relatively small, over billions of years it may be enough to prevent parts of the interior from freezing completely. If that idea is correct, Pluto could contain a hidden layer of liquid water beneath its frozen exterior. Such an ocean would be sealed beneath kilometers of ice, completely isolated from the harsh environment of space. While no evidence suggests life exists there, liquid water dramatically increases scientific interest because it provides conditions where complex chemistry could occur over extremely long periods. Another fascinating discovery involves Pluto's colors. The reddish regions visible across its surface are thought to result from complex organic molecules produced when sunlight interacts with methane and other gases. These compounds slowly settle onto the icy landscape, painting Pluto with shades of red and brown over millions of years. These materials are not biological. However, they demonstrate that surprisingly rich chemical reactions can occur even in one of the coldest environments in our solar system. With every new observation, Pluto becomes less like a forgotten dwarf planet and more like a dynamic world still holding countless unanswered questions. And if the first discoveries are this surprising, the greatest mysteries may still lie hidden beneath the ice. The more scientists study Pluto, the more they realize this distant world refuses to fit into simple categories. For years, Pluto was described as a frozen remnant left over from the birth of the solar system, a place where almost nothing had changed for billions of years. But every new observation suggests that beneath its icy exterior lies a far more complex story. One of the biggest puzzles involves Pluto's hidden interior. Although sunlight reaching Pluto is incredibly weak, the dwarf planet may still possess enough internal energy to drive slow geological change. Scientists believe that heat released from radioactive elements inside its rocky core could gradually warm the deep interior over immense periods of time. If that heat is trapped beneath a thick shell of ice, something extraordinary becomes possible. A buried ocean. Unlike Earth's oceans, this would be completely sealed beneath kilometers of frozen ice, protected from the harsh environment of space. If such a layer exists, it would completely change our understanding of small icy worlds. It would mean that Pluto is not simply frozen solid. It is a layered planet-like world with a rocky core, an icy crust, and perhaps a hidden reservoir of liquid water between them. Another fascinating mystery surrounds Pluto's largest moon, Charon. Rather than behaving like a typical moon, Charon forms a remarkable partnership with Pluto. Both objects orbit a common center of gravity located in the empty space between them, creating what astronomers often describe as a binary dwarf planet system. This rare relationship influences both worlds. Scientists continue studying whether gravitational interactions between Pluto and Charon may have affected their internal evolution billions of years ago. Understanding this relationship could explain why Pluto's surface appears younger in some regions than expected. Attention has also turned toward Pluto's strange weather cycles. As Pluto slowly travels around the Sun, its distance changes dramatically. During warmer periods, frozen nitrogen and methane escape from the surface as gas, forming a delicate atmosphere. As temperatures fall again, much of that gas returns to the surface as frost. Unlike Earth, where rain falls as liquid water, Pluto experiences a cycle driven almost entirely by frozen gases. This constant exchange slowly reshapes the landscape, redistributing ice across plains, mountains, and valleys over thousands of years. Meanwhile, sunlight triggers another remarkable process. High in Pluto's atmosphere, ultraviolet radiation interacts with methane molecules, creating increasingly complex organic compounds. Over time, these particles drift downward and settle across the surface, producing the reddish colors that make Pluto instantly recognizable. These compounds are not signs of living organisms. However, they demonstrate that surprisingly rich chemistry can occur even in one of the coldest regions of our solar system. Every discovery raises new questions. How long has Pluto remained active? Does its hidden interior still contain liquid water? Could similar processes exist on countless other icy worlds beyond Neptune? These questions extend far beyond Pluto itself. The Kuiper Belt, the vast region surrounding the outer solar system, contains thousands of icy bodies. If Pluto has remained active for billions of years, perhaps many of those distant objects are also evolving beneath frozen surfaces we have never explored. That possibility is transforming the way scientists view the outer solar system. Instead of a quiet collection of frozen relics, researchers now imagine a region filled with worlds that continue changing slowly over geological time. Future missions may one day return to Pluto. An orbiter could spend years studying its atmosphere, mapping its surface in extraordinary detail, and searching for stronger evidence of internal activity. More advanced instruments might even detect subtle movements within the ice or identify locations where heat escapes from below. Until then, the James Webb Space Telescope continues providing valuable clues from millions of kilometers away. Each observation improves our understanding of this remarkable dwarf planet and reminds us that distance does not determine importance. Sometimes the smallest worlds preserve the greatest mysteries. Pluto no longer represents the forgotten edge of the solar system. Instead, it has become one of the most scientifically intriguing destinations ever discovered, a world where frozen plains may conceal hidden oceans, where chemistry continues beneath a dim sun, and where every new observation challenges ideas that once seemed certain. Perhaps that is Pluto's greatest lesson. The universe is filled with places we think we understand. Then one new observation changes everything. And somewhere beyond Neptune, beneath layers of ancient ice, Pluto continues waiting to reveal its next secret.